guys, this is Anna again. Today we're gonna continue with the algebra. I will start a reminder from last year about the factorization with a bit of twist. From it, we're gonna go to solving a quadratic equation. To be started with, I will remind you about the distributive law. When we multiply two terms by each other, how do I answer this? You should be reminded that a monomial is a term that has only one variable. What does a variable mean? I call a variable, I determine it as a letter to say this can be any number. I can give p any number I want to still have 2 times p minus 1 equals to the expression I will have. I call this a variable. What does 2p mean? Does it mean p times p or p plus p? What do you guys think? When I am counting, okay, I say this is one box, this is two boxes. I don't multiply 2 by 2. I count them instead. This is one box plus this is another box, which gives me 2 boxes. So if I have 2p, it means I have p plus p. What does it mean to have 2p minus 1? How can I still say this is a monomial, whereas I have a coefficient here? You should be reminded that in powers, one of the powers can be power 0. So x power 0 is equal to 1 and not x. Okay? So if I have x to the power 1, this is x. For example, 2p, this is p to the power 1, minus 1, 1 is p to the power 0. Great. I should call, since p is a variable, the number or the integer that comes right in front of it, yani the number that counts how many boxes do I have, is called the coefficient of this variable. So here I have 2p, 2 is the coefficient of the variable p, minus 1. I can never add a variable to an integer, okay? How do I multiply this? The distributive law tells me I should multiply every number outside to every number inside the term. I don't multiply the coefficients with the variables. This is not 3p times 2p. This is not 6p. This is 6p squared because I multiply p times p, and I reminded you of the powers in the square root video. When I say p times p, this is p to the power 2. So I multiply the coefficients together, 3 times 2 into p times p. Now I should respect the sign of 1. Remember the table sign. Plus times minus, this is minus. Now, 3p times 1. Can I multiply a box by, for example, a pen? I cannot multiply a box by a pen. I multiply the integers together and the variables together. So this is 3 times 1 into p times 1. There is nothing. This is 1 times 1, for example. So this is p times 1. Three times 2 is 6. P times p is p squared. Minus 3 times 1 is 3. P times 1 is p. Let's try another one with square roots. The number outside should be multiplied by each term inside the parentheses, respecting, of course, the table of signs. So this is plus times plus is plus. Great. What is my variable here? I do not have any variables. The square root of 5 is a rational number. Remember, in the last video, we also learned that square root of a times n square root of a is equal to, this is the coefficient of this one is 1. So this is 1 times n and square root of a multiplied by itself twice. So this is 1 times 2, and this is square root of 5 squared multiplied by itself twice. Then plus times minus, this is minus. 1 times 3, this is 3 to the square root of 5. I can never multiply the coefficient inside the square root. This is not square root of 5 times 3. If you still don't know why is that, please go back to the last video. Okay, 1 times 2 is 2. Now, square root of 5 squared, remember, those are antibodies. They cancel out. So the square root and the power 2 cancel out. I'm left with 2 times 5 minus 3 square root of 5. And finally, this is 10 minus 3 square root of 5, and I'm done. I cannot add integers with square roots. Okay? I call this the distributive law. It means when I multiply a term outside to every term inside the parentheses respecting the signs. Why am I doing this? Because today we're gonna factor out a common monomial. A monomial means it has to have a variable and a coefficient or just integers. Let's see. Since the distributive law gave me 3p2 minus 3p, how can I go back to the factorized form, to a multiplication? I have an addition, I want to go back to a multiplication. How is that? We have to see, to check, where are the common parts between the two terms. First, are the signs the same? No, they're not. So I cannot factorize by the sign. Great. First, the coefficient. First step, we check the coefficients. Do they have anything in common? 6 is the coefficient of the first variable, and 3 is the second. Yes, they do have something in common. Actually, 6 is equal to 3 times 2. So I can factorize by 3. Why do I factorize by 3 and not by 6? Because I should divide here. I should put the remaining of the division of the bigger integer by the smaller integer, or the bigger power by the smaller power. Okay? So since 6 is equal to 3 times 2, if I remove 3 from this multiplication, what do I still have? It's 2. I am left with 2. Great. What am I left with? P2 and P. We also know same thing. P2 is actually P times P. This is a common factor between this P here and this P here. So I will take it into factor in common. Okay? What am I left of? P squared. I removed one P of its decomposition. I am left with another P. So this is the remaining. The division of 6P squared by 3P is 2P. Great. Since I have a plus sign outside, so I respect the signs, minus stays minus. Now, 3P divided by 3P. Since 3P is equal to 3P times 1, any number is, I can write it times 1. If I remove 3P, which is in common, what am I left with? 1 and not 0. Be careful. Because this is the division of 3P by 3P, as if I am dividing 5 by 5, for example. Do you say this is 0? No, this is 1. Right? Because 5 times 1 is equal to 5. So when I divide 3P by 3P, I am left with 1. Great. Let's do another example. 3x minus 15. I notice that the second term does not have any variables. No problem. This means the common factor will not have any variable. Let's see. The coefficient 3 of x, and we have the coefficient of x power 0 here is 15. Do they have anything in common? Yes, they do. I can write 15 as 3 multiplied by 5. I take the smaller one, the one in common, I take it outside as a common factor. So this is 3 into. Please, in a small notice, I already said it in the previous video, but I would like to remind you of it. When I put something outside a parenthesis, it means a multiplication. Either you put a point, you put a multiplication sign, or nothing. This still means multiplication. Great. So since I have 3x, if I divide it by 3, I took 3 as a common factor. What am I left with? I am left with x. So this is x minus, I respect the sign. 15 is 3 times 5. I have already used the 3 as a common factor. The remaining of the division of 15 by 3 is 5. So, and this is finally 5. So the factorized form of 3x minus 15, this is 3 multiplied by x minus 5. How can I be sure of my factorization? You can do the distributive law and make sure that you will get the same result. The distributive law tells me I should multiply the common factor by every term outside. So this is 3 times x, 3x, plus times minus is minus. 3 multiplied by 5 is 15. So yes, I have the same result, so my factorization is totally correct. One last example. I have a common factor between the coefficients and a common factor between the variables. Let's see. But can I write 15 as 9 times something? No, I cannot. So no, it's not 9, the common factor. This is something in the decomposition of both 9 and 15 which can be common. What is it? They are both multiples of 3. They are both multiples of 3. 9 is 3 multiplied by 3. And 15 is 3 multiplied by 5. So the common here is not obvious. You have to think about it. You have to find a common factor between them. So the common is neither 9 nor 15. It's in fact 3. One of the decomposition of 9 and 15. So I take 3 into a common factor. Let's check the variables. I have y squared and y. I know that y squared is actually y multiplied by y. And I have a y here, so this is the common factor. So I also take y as a common factor. 3y into multiplied by. What am I left with? If I divide 9 by 3 first, please, the integers together and the variables together, do not mix them. 9 divided by 3, I have removed the common factor, I am left with 3. It has also y squared. I removed one y, I am left with another y, so this is 3y. I respect the sign. Plus times minus is minus. 15 is 3 multiplied by 5. I have used the 3 of the decomposition of 15. I am left with 5. This is y now. Y divided by y, because I have used it in the common factor. This is 1. This is not 1. Y. خلاص. I have used the y here. I took it outside the parentheses. So this is everything. Okay? Another reminder, also the distributive law, but with two binomials. I say binomials instead of monomial because I have two variables, okay, inside the parentheses. How can I distribute this? How can I calculate this? I should use also distributive law from grade 8. Every term of the first parenthesis now, let's start with 3p, should be multiplied by every term inside the second parenthesis, right? And then I continue with the second term. Let's start. 3p into 2p minus 1. 3p multiplied by 2p. 3p into 2p. Plus times minus is minus. 3p multiplied by 1. I'm done with the first term of the first binomial. Let's start with 4. Now I want to multiply plus 4 by every term inside the second parenthesis. So this is plus times plus is plus. 4 multiplied by 2p. Plus multiplied by minus is minus. And 4 times 1. Okay? 3p multiplied by 2p, this is 3 times 2 and p times p. Do not mix them together. So this is 6p squared minus 3p plus 4 times 2 and 1 times p. So this is 8p minus 4. Okay? Now I should reduce them. I take all the degrees of p together. P squared, I have only one term in p squared, so I cannot add it with anyone. This is 6p squared. 3p, I have two terms in degree 1, which is 3p minus 3p and plus 8p. So this is plus 5p. And I have an integer alone, negative 4, negative 4. Okay? And finally, another example with square roots. Also, I should multiply every term from the first parenthesis into the terms of the second. So this is radical 5 multiplied. Radical 5 multiplied by 2 radical 5. Plus times minus is minus. Radical 5 multiplied by 3 plus 1 into 2 radical 5. I am doing the second term now. Plus 1 into 2 radical 5 plus 1 into negative 3. And negative 3 times 1. Let's calculate now. 1 times 2 is 2. Radical 5 times radical 5 is 5. Minus. Square roots and integers separated. So this is 3 radical 5 plus 2 radical 5 minus 3. And finally, this is 10 minus 3 is 7. Minus 3 radical 5. They are alike radicals. They have the same radical. Negative 3 plus 2 is negative 1 radical 5, but we don't write the 1. This is 1. This is minus radical 5. Okay? Why am I doing this? Because also I will use the distributive law, the reverse of the distributive law, to factorize a big expression that might have common factors. Okay, how can I know what are the remainings? Okay, let's see. In the first example, I have x plus 2 into 3x minus 5. This is the same as the first example. Plus, be careful, this is not a multiplication. Plus another product. So this is the first product. And this is the second product. And I have the sum of them. I want you to write the factorized form, the final factorized form of this big expression. How can I do this? I notice that there is a common monomial between the two products. x plus 2 here and x plus 2 there. So I can take x plus 2 as a common factor, like the one we did before. For example, I have 9 and 15. They are both multiple of 3, so I take 3 in common. This is the same thing, but with polynomials, okay? So this is x plus 2 in both products, so I take x plus 2 as a common factor. What am I left off? Before we have done that, for example, if 12 is equal to 3 multiplied by 4, if I take 3 into a factor, a common factor, I am left with the second term of the product, right? So if I took the first term of the product, what am I left with? I am left with the second term, which is 3x minus 5. Okay? Now, I leave the sum as it is. I do not change the sign, either the sum or the subtraction. I do not change the sign. So this is plus. Now, from the second product, I have taken the first term. What am I left with? I am left with the second term of this product, which is 7x plus 9, the same thing. Parentheses, I am left with 7x plus 9. Okay, so this is a multiplication, do not forget. My first step in the factorization. What can I do now? Let me minimize it a bit. Okay. Since I have an addition inside the parentheses, I can just sum the alike terms, okay? So I have x plus 2 as a common factor into 3x plus 7x together, because they are both coefficients or multiples of x. So this is 10x. Negative 5 plus 9, this is plus 4. Okay? If you are wondering how could I directly sum 3x and 7x whereas they are into parentheses, this is because I have a sum, I have a plus, so the parentheses do not matter anymore, as if they weren't there. Now I notice, guys, that in the second term, I still have something which is in common between them. What is it? 10, I can write 10 as 2 times 5. They are both even numbers, and 4 is also an even number, 2 multiplied by 2. So I can continue my factorization by taking out my common integers, which is 2. So this is equal to 2 into x plus 2 into. Now, 10, I took out the 2. What am I left with? I am left with 5x. Do not forget the x. Plus 4. I took out 2. I am left with the second 2. So this is 5x plus 2. I would like you to pause this video here and try to redo this expression all alone and check your answers. The same example, but I have a small twist in here. In the second product, I do not have exactly the same term as the first one. I have negative x, negative 2. I cannot directly take x plus 2 and negative x minus 2 as a common factor because the sign matters in here. I cannot take it out. What can I do? How can I modify negative x, negative 2 to be x plus 2? Since they are both negative sign, I can take out the negative sign. So, let me first rewrite it. The first product stays the same, x plus 2 into 3x minus 5. Now, I will take out the negative sign. So this is plus into. I will take out the minus outside, minus parentheses. When I remove the negative sign of x, what am I left with? I am left with x. When I remove, what is the opposite of negative 2? If I have the negative sign outside, this is plus 2, positive 2. Okay, so this is how I change it into the same factor, and 7x plus 9. Okay? Now, plus multiplied by minus is minus. So I don't have a sum anymore. I have a subtraction now. Okay? I will write the new expression. I cannot. It's okay. Okay. So this is x plus 2 into 3x minus 5. Plus times minus is minus x plus 2. I changed the whole operation into 7x plus 9. Now I do have a common factor, and this is x plus 2 into, open the brackets, from the first product I get 3x minus 5. I am left with 3x minus 5. I respect the operation, which is a subtraction, so this is minus, parentheses. From the second term, I am left with 7x plus 9. This time, I cannot directly remove the parentheses. I should respect the table sign, because now I have x plus 2 into. I have a positive sign outside the parentheses, no problem. So this is 3x minus 5. But now, minus into 7x, this is minus 7x. Minus into plus 9, this is negative 9. Okay? So this is so much different than this answer here. So x plus 2 into 3x minus 7x, this is negative 4x. Minus 5, minus 9, now I have a totally different answer. Now I have negative 14. Okay? If you would like, you can take out the negative 2 outside, and you are left with 2x plus 7 in here, as you want. And thank you for watching for today. In the next video, I'm gonna continue using the factorization to solve quadratic equations.